So this is DLA course 4, and the course name is Introduction to Big Data and Hadoop. So this is, I mean, it's not just only to know what is big data and Hadoop. It's also to know how to configure small big data setup and how we can start slowly using the big data internals and how it works under the hood. That's very important if we need to either want it to be administrator of a big data platform, or we want to develop something, or we want to do some decision whether we actually need the big data or not. So all these questions, I hope after this training, at least in high level, uh, all can answer by themselves. So I am skipping, I mean, my introduction that is already been given by Sir. So just going to the course details. So I think everybody has reviewed the overall agendas of this course. So today we are going to discuss, I mean, just the fundamental concepts of big data. And then in the next class, we will be understanding the Hadoop components, and then how to set up Hadoop practically in an environment. And then we learn the distributed computing framework Spark is the 4th course, and then how to configure this Spark. And in our course, it's very important that we'll be using Linux CentOS, and we'll be using Python as our programming tool. I don't know how many participants knows about, I mean, Python and familiar with Linux OS operating system. So I'd request, I mean, so the practical works is from the 3rd class. So in the meantime, you can, I mean, go through basics Linux commands and Pythons. So that would be really helpful. And then we'll do some programming on top of Hadoop and Spark. And in the last class, we'll be solving one real life problem. After that, I think you will be able to understand, I mean, how to design a small, I mean, big data problems and solve. So as part of today's agenda, what we are covering, let me just go through it. So it's just, I mean, what is big data, right? We just need to know conceptually when we are saying big data, what does it mean actually? And interestingly, how big the big data is, right? And within the big data, what we are trying to solve. So how big data comes and what we are trying to solve. And then we'd like to understand what type of data exists in real world, and Hadoop system principles, the history of Hadoop, and what is the problem in our relational database management systems. Like we used to, I mean, use MySQL, MS SQL, and what is Hadoop ecosystems and the distribution that we'd like to use, and what are the supported OS and hardwares. So let's start, I mean, with the very first, I mean, what is big data, right? So big data, I mean, so we are now in an age where we regularly, I mean, deal with the big data, right? The very first example that I would like to give is the Google search. So we are just writing something and Google is giving us a lot of relevant results within milliseconds, right? And we all know how big the internet platform is nowadays. Every day new websites are coming, and Google is, I mean, indexing all the new websites, and it has all the historical websites there as well. Sure. So how Google and their algorithms is fetching all the records within milliseconds, and how they are managing is already part of big data. And one interesting fact is that the 90% of the world data is generated in last few years, because as soon as we introduce the internet platform and we cover our villages and worlds using 4G, 3G technologies, right? So we used to, I mean, interact with a lot of applications, Facebook, YouTube's, many different websites, e-commerce sites, and even airline black box, many sensors data. So all these data are generating every day. And we are searching a lot of data in many different regions. So now if we'd like to, I mean, define, I mean, what is big data? So big data uh, is really a big data, and it's a collection of large data sets which cannot be processed using traditional, I mean, processing technology, as well as it cannot be stored in traditional storage. That we should call, I mean, big data set. And big data is a complete subject which involves, I mean, various tools and techniques and frameworks to handle large data sets. So if you have any specific question, please write by yourself. So after the sessions, I think we'll go through each questions. So that's the strategy. So I know maybe some of you have some questions in particular topic. So the next one is, how big is big data? So this is really a tough question. So there is no such, I mean, specific numbers that we can say, okay, these terabytes or these petabytes of data, we should say big data, right? So it depends on, I mean, how the persons or individuals or companies are dealing with the data and what is their use case. For example, for Facebook, I mean, 1,000 petabytes, they would mean as big data, right? But for a telecom or bank, maybe 100 terabytes. So it depends. So there are key, I mean, parameters based on I mean, we can understand whether it's big data or not. So the type of data the companies are handling. I mean, what type of data? We learn, I mean, in today's course as well, what type of data exists in, I mean, real world, and the latency expectation of data that they are processing. So let's say we went to an ATM and we put our card and asked for some money, right? So what is the expectation to the ATM will provide us response, right? It should be few seconds. It's not minutes or I mean hours. And the cost of storage that we can afford, or a company can afford, the amount of data that we are dealing with, what is the cost to store all this data, and how fast the velocity of data that we are dealing with. So all these questions, I mean, is related whether, I mean, we are trying to say is a big data sets, or we are trying to say we need to deal with the problem with big data. So see, in big data, why it's now very important. It's not now. I mean, since 2004, so Google developed their own big data technologies, and after that, it has been handed over to, I mean, the open source community. So now, if we see, I mean, how much data we are generating daily, it's just in some recent snapshot I collected from the internet. So more than 3.7 billion people are using internet. And out of that, on an average, Google is processing 40,000 searches per second. And Facebook is generating itself 4 petabytes of data per day. And they are having 1.5 billion active users daily. And users, I mean, watch 5 billion YouTube videos per day. And in Twitter, there are around 500 million tweets sent per day. So, I mean, if we need to build one application, right, where we are receiving 500 million tweets, for example, I mean, what database, I mean, how we should design. So that's what, I mean, is the problem that we are going to solve using big data. So it requires distributed storage and distributed computing. Otherwise, in traditional the way we design, for example, an e-commerce site, so it would not be able to handle this kind of loads. So now, if we understand the basic problem of applications or use cases that would require big data technologies or tool sets to be used, those are mainly two. One is, I mean, how we would need to store a large data set. And that is not only that we need to efficiently store large data set, it has to be cost effective. As I said, right, this technology is brought to us initially by Google, and their fundamental problem was how they can search a huge amount of data based on users' queries, and within a milliseconds, get the relevant results to the users. From that started, and now it has been used, I mean, in many places. Just for example, 1 terabyte of external hard drives that we use, I mean, in regularly, right? In university student also knows. So it's mainly 5,000, I mean, in Bangladeshi data, right? But if we think about 1 terabyte of enterprise disk array, that would be, I mean, 1 million plus PTT. So it's really a significant cost difference if we use any enterprise level big storage system to store our application data. Maybe if it's within few terabytes of 100 terabytes, that can be still manageable. If it's 1,000 terabytes, it would be too much cost, I mean, just to store application data. And then, for example, somehow we would be able to store the large amount of data. Now, if you want to search something, or if you want to get a specific information out of all the data sets. So, I mean, how we should, I mean, perform a query on top of a large data set, which will give us result within milliseconds or within an expectable amount of time. Because all queries are not required to be responded by milliseconds or seconds or minutes, right? Some queries may require, I mean, let's say 1 hour. Maybe we just want to do some analytics on lot of data sets. If it's coming within an hour, it's fine. Because within traditional, I mean, processing technology, it might take, I mean, few days or more than a week. So if I get within an hour or few hours, it's fine. So it depends on the use cases. So it's also important, I mean, after storing a lot of data, I mean, large data, it's also important to fetch those data or analyze those data within an expectable amount of time. That is also a challenge. So I mean, in any of our application design, if we think we need to face this kind of problem, then big data is one of the potential solutions that we could think. And in terms of data processing, if we see, I mean, 1990, for example, if we buy a hard disk, right? So that maybe can store 1400 megabytes, and the transfer speed was 4.5 megabytes per second. So that means, I mean, a whole disk we can read within 5 minutes. And now, if we think about external storage, which is 1 TB, and if the speed is 100 megabyte per second, the read speed, then we may need to, I mean, take 3 hours just to read the whole disk. So, I mean, searching records in a particular the general purpose storage, it does not help for, I mean, large data sets. So maybe as for some response, it's few hours. We cannot wait. It needs to be within milliseconds. So now we are talking about, I mean, the large data set, but most importantly, what are the data we are trying to mention? It can be even audio, video, plain TXT, can be HTML, can be XML, any type of data, binary data. So in a standard way, we can say that there are 3 types of data. One is structured, semi-structured, unstructured. So types of data structures that we are discussing. I mean, in general, there are 3 types of data structure, and when we were a student, right? So we used to deal with mostly structured data set, right? The application we developed in general. So there are, I mean, structured data set, semi-structured, and unstructured. So when we say structured, so it's very easy to, I mean, define. For example, we do, I mean, design our applications in relational database management system, MS SQL, MySQL, Oracle, Sybase. There are a lot of database we generally use. But the fundamental definition is, I mean, the data we are storing in RDBMS that have a specific schema. I mean, if we define a table, so we need to define the column names as well as the column, I mean, the data type. So the overall definition is known to us. So that is called structured data. So we know what data we're storing, what is their data type. So that is structured. Now coming to semi-structured, think about an HTML or XML or a specific CSV file, which may have the headers or may not have the headers. So we know a certain structure of the data, but we are still not sure what is their data type. For example, in a CSV file, we have project, I mean, course name, attendee names, dates, and who is submitting assignments, and how many classes anyone can attend. Let's say these are the columns, and there are rows we inserted and saved in a CSV file, but we still don't know which columns we need to consider in which way. Is either, for example, the date we need to consider as a date or as a string. I mean, how? If there is some columns storing some integers or floating value, how we need to, I mean, represent that one. That is not clearly identified. So that's why that is semi-structured. I mean, we will get half schema idea, but it's not full. Now coming to, I mean, the third one, which is the most data that we have in our world, that is unstructured. So I'm taking this course, it has been recorded, right? So this is also a data, it's unstructured. And this presentation, unstructured. And a flat txt file, a letter to someone else, is unstructured. Some random binary data, image, audio, video, everything unstructured. So in unstructured data, there is no schema, there is no data types. So if we need to deal with the unstructured data, the programmers or the data engineers, they have to decide based on the use case how to deal with the data. I mean, whenever we are searching, I mean, for a website, I mean, so Google is searching all the available websites they have indexed. And if we are considering all our websites are HTML, CSS and all, so they are looking keys to compare a specific data set to be retrieved for the user. So it's not something, I mean, what we use generally in a RDBMS query, to select, I mean, that website from a specific table, right? It's not like that. So for dealing with unstructured data, the programmers or data engineers, they have to, I mean, define how to deal. And big data and the big data tool sets are giving the technologies that can be used to analyze all three types of data: structured, semi-structured, and unstructured. And it's really good and efficient to process semi-structured and unstructured. So, so now, just before, I mean, starting this Hadoop system principle. So big data is, so it has basically, I mean, as I said, the Google has invented the technologies initially, and then it has been handed over to open source community. And the Apache Hadoop is well known open source project, which is very famous project nowadays. So many industries are using this to solve their big data problems. So now we'd like to understand, I mean, what is Hadoop system principle? We'll slowly know more about Hadoop in today's session as well as the upcoming sessions, even with, I mean, practical flavor. So Hadoop is a set of cheap commodity server hardware networked together. It generally resides in same locations, in same data centers. But nowadays technology is very, I mean, evolving very fast. So it is working in different geographical data center as well. So when we say the cheap commodity hardware, so we need to understand one thing, that they are not supercomputers or expensive computers that we generally use in heavy IT industry. And also they are not even our laptops and desktops. So they are a medium range of, I mean, servers. So the configurations and the resource details we also look into within our course. I mean, what is the standard server configuration that we are talking about just to build standard Hadoop cluster? So it is not required to purchase state-of-the-art hardware, which is really, really expensive. And it's not that we should run Hadoop production cluster using our desktops or laptops. But yes, we always can configure Hadoop cluster using our laptops or desktops for our development or learning purpose, not for any application production purpose. So Hadoop is principally is lot of commodity servers which is working in a cluster mode, and it is being used for distributed computing and distributed storage. So the key principles that Hadoop brings for us, and out of the important ones, I collected few ones which we need to discuss and understand. Number one is scale out rather than scale up. We'll discuss more. Second one is keep our code or logic and the data on which we will apply the logic and code in the same place. Deal with failures, taking complexity in software level, not in the hardware level. So you'll understand more, I mean, when we'll explain detail. Abstract complexity of distributed computing and concurrency in under the hood. I mean, the developer or the administrator, they won't know, I mean, how it works, but underlining it is giving a layer and it is hiding all the complexities from the developer. So just the first one, scale up. What does it mean? I mean, for example, we have a solution, and the solution we have, for example, 3 servers. In the 3 servers we are running, let's say 2 Windows OS, 1 Linux, CentOS or Red Hat. And we feel that in the application we need to increase the CPU memory because the user load is high. So when we expand each of the servers or any one of the servers, I mean CPU RAM within that server, that is, I mean, scaling up. So we are adding resources within existing nodes of our solution. That is scaling up. So it's harder and it's costly, and sometimes it has a limitation. For example, in a server we have 16 GB RAM. So we may up to increase 64 GB RAM. When it filled up, what will happen? So scale up comes with its own limitation. But when we deal with large amount of data, it can't be solved within a certain amount of CPU memory that a single server can hold nowadays. So scale up, I mean, it can't be a solution for us. So in Hadoop, so it always supports scale out. It means that initially, let's say we set up a Hadoop cluster with 3 or 4 nodes. When I say nodes, you can consider for virtual machines or physical machines, whatever. And then when you think that, okay, today we need to handle 10 terabytes of data, and after 1 year, you understand, okay, I need to handle 100 terabytes of data. So I need to add more 3 nodes. So then you just prepare your 3 nodes, add to the cluster. Within one single Hadoop platform, you can easily manage 100, 1 terabytes, whatever you need. So you can add as much as nodes you want. It's very easy to scale. I mean, as soon as you prepare your node, the addition of the node might take maximum hours. I mean, with the expert hand, it should be done within, I mean, half an hour. So this is supported. I mean, the scalability is solved. If we are starting with 10 terabytes and we need to expand to the thousands of terabytes, you can do that, which is not doable, I mean, scale up approach. The second point is very important. I mean, we all familiar with developing an application, and we in general purpose solution and system, we do use a RDBMS where we store all the data, and we have our application logics and details in a separate, let's say in a separate servers from where we run our codes, and it will fetch data from the storage, and we calculate or run our logic on top of data. After that, the output also needs to be written back to the data storage. So that is the way, I mean, the traditional data processing is, I mean, working nowadays. And there are a lot of applications running like this, because this approach is true, and this will be true for many applications they would need. For example, this project is having a website where all the events are managed. So it does not require, I mean, the big data processing, right? So the traditional data processing techniques is sufficient, and we have to do that. So this is the way, I mean, if we need to follow the approach for computing on large data store, that might take a lot of time. So this approach has to be changed. So in big data, what we are doing, so for example, these are 4 nodes in our Hadoop cluster. In 4 nodes, you see that we have application code and data, we have application and code and data. So basically from the user point of view, when we more detail on Hadoop, we'll understand that how the users are assigning jobs to Hadoop cluster, and how that programming or that code is being distributed to multiple nodes. And on top of a specific data set on where the logic should run, the data is already distributed in Hadoop cluster. So that we will understand in more logical and practical way. For the time being, just try to understand that the application code is running within the data set that is residing in that node. And then it is giving the output to a master node, and the master node is collecting all the outputs, and it has been forwarded to the users. So code can access data locally, and that brings a lot of efficiencies and reduction of processing time. Another important things, I mean, one question we should have always in mind, that we are not using state-of-the-art storage and servers. That is always, I mean, offered by the renowned vendors, right? The Oracle, Sun, HP, Dell, Lenovo, right? So what they are doing, I mean, in our traditional techniques, as I said, we are doing and will be doing a lot of traditional methodologies to support our regular applications or solution need. So there we are using, I mean, many HP plates or Oracle standard solutions. So here, if we know, there are network connectivity, I mean, redundancy, there are storage level redundancy, there are, I mean, in RAM level also there are. So everything is physically redundant. So that if something goes wrong in server's components, finally the applications can still run. And within the state-of-the-art server, there also we could do clustering techniques so that if one whole server is down, still we can access applications. But as we are not using state-of-the-art servers and storage in Hadoop cluster, so now how we can ensure that the data is stored in a reliable way and the whole cluster can still sustain in hardware and software failures. So we'll know in detail, as I said, for the time being, so we are using commodity level servers or hardwares within the Hadoop cluster, which does not have that much, redundancy in physical layers within itself. And that's why it's cost effective. So all the failures that generally happen in a Hadoop cluster, let's say one physical server has two disks. One went fail, RAM failure, whole node failure. How, if there is some jobs is running, how the job will be accomplished. So that's why the point is broken down jobs to tasks, and all the tasks assigned to the nodes are timeout control. Whenever there is a user jobs assigned to a Hadoop master node, so that job will be broken down into tasks and it will be distributed to all the nodes who can perform tasks. And if some nodes is not giving result within a certain timeout period, the master node will decide, okay, I won't take your result. I am reassigning you tasks to another node. So in that way, task level or the distributed computing failures can be achieved. Now, if a whole node is also down, so we store the data also in a distributed format. If one node is down, how can we, store data which has been, kept in that specific node? So whenever user is putting a specific file, let's say 1 gig file, it has been broken down pieces of block, and those blocks will be distributed to n number of nodes out of, let's say, 100 nodes. And what is the n? That will be decided by, the Hadoop administrator. We will configure. Let's say in a 100 nodes Hadoop cluster, we'll configure the n is 3. That means a block will be copied minimum 3 places. So if one node is down, second node is also down at a time, so you can still access the data. So all these techniques, we'll also see how to configure and what's the impact. Why I'm saying it's 3, why it's not 2, why we are not keeping data in 10 places. So that's also a concern or question. So we'll discuss more on that. So the fundamental things is that all the beauties that we are getting on the state of the art, all these challenges we bring into the software layer, and in the hardware layer we are using commodity hardware so that we can reduce the cost of processing and storing significantly. That's one of the big outcomes. So that's why whenever a user or a programmer assigning a job to Hadoop cluster, so for them basically it's totally abstract layer. So for example, we have 4 nodes here. Each node is having 100 gigabytes. So let's say our overall the capacity is 400 gigabytes. So the user who is assigning the job, he will see, okay, I have a 400 gigabytes of space. So that is a, distributed accumulated state you will see. You will not see, how it is internally distributed. It does not matter for the users, or some kind of, I would say, for developers. But for a developer or a Hadoop administrator, they should know how internally Hadoop is processing and managing the data. Because whenever we are writing a program and it's giving an error, the error is not related to my programming logics, but the error is mostly related coming from the platform side, this memory, out of memory, and a lot of stuff. So we'll see those things. So those needs to be handled, and one can only handle if he or she knows, I mean, how under the hood Hadoop is working. So I'm just recapping, because these are very important. I mean, the Hadoop principles. So scale up is not, I mean, solving our problem for large applications. So we have to think about scale out techniques, and that Hadoop supports. We cannot keep all the data in one place. So we need to keep data and code in the same place, and make sure a computing platform can compute some logic on some data, and someone will be there, I mean, working as a master to accumulate all the results and give it to the result, I mean, the users. Deal with failures. So underlining, as we are using the commodity level hardwares, so we would expect failures of whole nodes or part of nodes, or there can be issues on the software level as well. So the Hadoop clusters, the frameworks that should have the capability to deal with the failures, that end user should not be impacted. So the story of Hadoop. So I got chance, I mean, to be interviewed with, I mean, Google site reliability team looking after Gmail and Google search. And after a couple of interviews, I got rejected in 2015. So the interview was running, I mean, around 1.5 months. Within that period, so they gave me a lot of stuff related to Google, and I did study. And from there, the big data interest, I mean, it comes from that failure. So, as I said also in initial phase of my class, that in 2004, so Google published Google file system and MapReduce frameworks papers. And there they define how they are storing a large amount of web data. And within the web data, how they are searching, how they are analyzing using MapReduce framework. So GFS is called as a Google file system. So here we'll say Hadoop distributed file system. By the way, I mean, I hope everybody understand what is the role of file system in an operating system, computer operating system especially. So in a layman term, if I would like to say, the file system is managing the user's data. User should be able to create, delete, update, append files in an operating system. That's what the file system is doing. Just to relate to your thoughts, I mean, the NTFS FAT32 is a renowned file system in Windows. And in Linux, if you remember ext3, 4, and from Red Hat 7 or CentOS 7, the XFS These are the file systems that is used for general purpose processing. So these Google file system, or the file system that we are talking about, I mean the Hadoop distributed file systems, that will be basically running on top of the traditional file systems. So GFS is also like that. And then if you see the big table is Google's large structured data storage. So this big table is a structured data storage, but it's built and it's run on the GFS, so that it can process large amount of data. And whenever any search is being performed, they are using the MapReduce, which is a distributed computing platform. So after releasing this paper, yes, GFS is a very proprietary things for Google and it's not for sale. But for the open source community, so they have shared their techniques and details, and later on a team formed, and in 2006 Yahoo hires Don Cutting to work on Hadoop with a dedicated team. And later part, it has been given to Apache Foundation for further level enhancement. So a lot of people around the world are continuously contributing and updating the Hadoop repositories. And in 2008, the Hadoop became the Apache's top level project. So if you go and click this URL, you will find more details about Hadoop architecture, the different versions of Hadoop, and what is the stable version. So stable version means, I mean, when we are really developing some production application, we should use the stable versions. One of the challenging things of using open source stuff is when we build some application, then if there is something wrong within the framework, it's very tough to dig down and get support from the community. So for Hadoop especially, there are solutions, so we'll see today. So what should be actually we should be using in the production platform. So now I think, I mean, many of us is thinking what is wrong with our relational database that we generally use. Oracle, Sybase, MySQL, MS SQL. So we are generally very handy with all this stuff. So these applications are generally built for real-time transactions, as I gave an example like ATM transactions. And nowadays, Oracle, Sybase, MySQL, MS SQL, they also support batch processing. Means they can process a lot of data. Hadoop is not fully replacing RDBMS. So there are many applications, there will be many applications which still can run on RDBMS because many applications won't need a lot of data to be processed. And for those applications, Hadoop will be inefficient. So scaling up RDBMS is still a concern when the database is crossing 100 terabytes. However, in Hadoop cluster, I mean, we can add 1,000 nodes, for example, to handle petabytes of data. That is possible. So if we have storage of 1 terabyte and we are adding one node which is giving us 500 GB of storage, then If we add that node, our storage, I mean the Hadoop cluster distributed file system capacity will be 1.5 terabyte. So this is the way we can add and scale our storage capacity easily in Hadoop. RDBMS store relational data, meaning structured data set. It will be having specific columns and the data types. However, Hadoop is best to store unstructured and semi-structured. So don't get me wrong, Hadoop is also able to, process structured data. But it is best to store unstructured and semi-structured. So Hadoop performs best for offline batch processing on large amount of data. However, certain NoSQL database named HBase can give low latency query, but with limited query features. So when Hadoop is built initially, so it's built for offline batch processing, meaning so you want to do some analytics on a large amount of data sets. So you put a query and it's running in a distributed fashion. So maybe you will get result in half an hour time on very large amount of data. So later on, there are use cases that Hadoop has to support some real-time query as well. Then on top of Hadoop platform, there is one database like Sybase or Oracle, it's called HBase, which can give us low latency query output as well. But the query that we are talking about in HBase is not the SQL that we used to write. So it's a different kind of syntax we need to learn. There are solutions on that aspect also. I mean, the way we think and we build application in traditional technologies. So it's good that in Hadoop and big data also, the experts or the contributors think about that. So there are solutions to write the distributed computing queries like SQL we used to. So we'll do that within the course. We'll see how it runs. Hadoop was not designed for real-time and low latency queries. But as Hadoop evolved, it is required to support real-time and low latency queries. And that's why there are solutions like HBase. And Hadoop is designed to stream large files and large amount of data. So it's meaning, for example, we have a very popular Facebook page and people used to give comments, likes and everything. So if I open API for getting all the reactions and comments and everything that is coming to my page, that all the data would look like, like a stream of data. So one of the property of big data is the velocity of data. So the Hadoop is designed also to handle that. The way data can come, very fast. A lot of data can come in a very fast. Within a milliseconds or seconds, maybe there are a lot of reactions. So we need to process those data, and that is also supported in Hadoop. So yet still RDBMS is best for online transaction and low latency query on small records. So we should not use Hadoop for processing, low scale database queries. In some cases, you will see inefficiencies. Just to, there are a lot of theories today and the next class. So, so that we are not, I mean, relating what the problem we are solving. And I prefer to keep this application concept so that we understand, I mean, how practically we should think about a solution design, including a relational database and using Hadoop, both. For example, application architectures that can keep both Hadoop and RDBMS. It can be, let's say, we we develop one e-commerce applications, and for example, we have 100K visitors regularly in that platform. So, so that can be still handled through a RDBMS. But if we have 100K users, that doesn't mean that one user is searching every day. And if one user is active in my web page, they might be interested to click in many pages, which will trigger a lot of requests to our web servers. At the end of the day, if we would like to analyze the web server logs that's stored in our web server, and if we see the web server log format, the IPs, the HTTP request, and what the page or in whatever it's requesting HTTP protocol, this is an unstructured, I mean, semi-structured data. So you understand, I mean, how it is organized, how to interpret with the data when we actually see the data format. So this is an example of semi-structured data, and this data will be very large. So if I want to, I mean, I want to order one dress in a e-commerce site, maybe I have to click at least 10 times. So everything is being backend is calling HTTP service, right? And it can be get, post, whatever. So those every transactions and details is logged in our web server. And for security purpose or any other purpose, if we want to analyze our web server logs, it's better to keep those logs in Hadoop and process those queries, even stored, let's say, last few years back. So we should be able to process those and find the insight that business needs. And after analyzing the web server logs using Hadoop, you can still put the summary of the analytics into the RDBMS so that user can see. Yes, the application UI can also connect to Hadoop. There is a way, but it's easy to, I mean, connect and store in a RDBMS the resulting query. So this is the way, I mean, one can and think about for a simple case, I mean, how we can use Hadoop. So if we talk about, let's say, ride sharing apps, so the real-time transaction can be done with an RDBMS or with a NoSQL DB like HBase, which supports real-time queries or low latency queries. But in the backend, if we want to analyze which customer I need to give a certain amount of offer by analyzing a lot of data and customer behavior, that can be done using Hadoop by keeping all the user interactions in a separate HDFS or Hadoop distributed file system. So Hadoop, in principle, so as we mentioned already, that there are two problems mainly. One is distributed file storage and distributed computing. These are two basically solutions, but the problem is how we should, store large amount of data in a cost-effective way, and how we should process a lot of data in a cost-effective way. So there are two solutions for that particular two problem. So one is HDFS and another is MapReduce. So what is HDFS? HDFS is Hadoop distributed file system. So this HDFS will create one software layer on top of our underlying file system given by the OS, and it will give you an abstract layer to store all of your files. And it's totally a special kind of file system. For example, in our Linux file system, XFS, the way the file blocks are managed can be maximum 4K bytes to 64K bytes. But in Hadoop, the minimum block size is 64 megabytes. And it's used to store large data set in distributed environment. Of course, using a commodity machine, not on top of state-of-the-art machines. So this will solve our large data storage problem. Now, if we need to find out any specific topic on top of that large data set within the expected time, so we need a distributing computing framework, and that is MapReduce. So why the name is Map and Reduce? There is a reason, and we'll see with an example in the next class, just to see how it works and why it MapReduce. Coming to Hadoop ecosystem, when you say ecosystem, meaning all the tools that is being, evolved. So if we go to Apache Foundation website related to Hadoop ecosystem, there are a lot of tools nowadays, because worldwide the contributors are having a lot of problems, and they are coming with new ideas and solutions, and hence there are a lot of tools nowadays available to process big data under one umbrella, and that's what we are saying Hadoop ecosystem. So I picked up a couple of things here. So there are, if you visit that hadoop.apache.org, you will see a lot of stuff there. So HBase, we already talked about that. We know what is HDFS and MapReduce. So HBase is basically a column database which support both batch and real-time queries. But again, I'm saying the query that we used to write is SQL, and the format is not like that. It's a different format and syntax which we need to learn before using or building any application on top of HBase. But underlining, it will work on HDFS. So Zookeeper is a highly available coordination service. So it is like, I mean, to ensure high availability of Hadoop platform, so we can use Zookeeper. OG is Hadoop MapReduce workflow scheduler and manager. And Peak is a tool, I mean a language, like SQL, data processing language. So we can write human readable query using Peak on top of large data sets stored in HDFS. Hive is a data warehouse with SQL interface. The interface will be similar like SQL. So Hive will give us SQL-like interface, which we really easily can connect. And the next one is Spark. We should say Apache Spark. It's an in-memory distributed computing framework. So in our course, we'll use HDFS and as a distributed storage platform, and Spark as an in-memory distributed computing platform. MapReduce will understand how it works because this is the base distributed computing platform, but it's very hard to write MapReduce code for every problem we generally face in real life. So that's why the contributors are taking Peak, Hive, Spark SQL type of things so that we can write queries, SQL type queries, which will be internally converted to MapReduce queries, and it will run in a distributed fashion. So we'll use Spark as our distributed computing framework, and it will be very easy to understand and connect with the distributed computing framework. So if you like to, I mean, download the HDFS, MapReduce, the binaries, you can visit hadoopapache.org. So as I said, to use the base distribution of any open source projects, especially Hadoop ecosystems. So let's say you are using Hadoop, HDFS, and HBase. So you need to know, I mean, which version is compatible with which version. So that is a common issue. So that's why globally there are a lot of vendors working on that, and they are making one combined package. Within that, all these required basic ecosystems are clubbed together, so that as a programmer, we won't need to think about the compatibility issues and others. One of the distribution vendors named Cloudera Distribution for Hadoop, CDS. Another is Mapper. One of them is Hotor Networks Data Platform. So Cloudera is one of the leading distribution in Hadoop, and they employs large percentage of core Hadoop committers. So the persons or contributors who are contributing to open source Hadoop, most of them are employed by Cloudera. So we'll not use Cloudera distribution for Hadoop or Mapper or Hotor networks. We'll definitely use base Hadoop and Spark Hadoop libraries, so that our intention is to know how things works underlying. And when you understand the basic things of Hadoop, Spark, and the need of distributed computing and storage in specific use case, then you can easily switch by yourself to Cloudera or any other standard distribution for your production work. It will be very easy. So as I said, we are not using our laptops or desktops in Hadoop cluster, and we are not also using, the state-of-the-art servers. So now what does it mean? It's very confusing, right? So that's what I thought to highlight a small pieces of information which will give you a standard Hadoop production nodes resources. So generally in a Hadoop node, the CPU should be at least 8 physical core to 12 physical core. Memory can be from 16 GB to 48. The internal disks can be from 4 terabyte to 36 terabyte. And it's better to be at least 1 gigabyte to 10 gigabyte Ethernet. And this should be redundant. That is better, it's recommended. So if you see just, a picture of Yahoo Hadoop cluster, is one picture I collected from the internet source. So it's a Yahoo Hadoop cluster. So we know that Yahoo has a lot of services starting from email and others. Now, which software, coming to operating system, which operating systems are supported by Hadoop? It should be always Linux, and it supports Windows and Mac OS, but it's only for development purpose. If you need to run a production platform, it is always advised to run on Red Hat Linux if it is an enterprise applications, but you can use CentOS, for educational purpose or development purpose. So we'll be using CentOS 7 here, and it's recommended to use CentOS or Red Hat 6. After 6 version should be. So we use CentOS 7 in our lab, and Ubuntu is also supported. I know many students prefer Ubuntu, but I would prefer here CentOS. So if you are a bit familiar with Linux commands, basic commands, how to browse file systems and how to edit, update a file, that would be really helpful for this course. And before the next class, I will also try to provide some, URLs so that you can go through and you get prepared, because we're starting the hands-on things from the third class, if I correctly remember. So before that, you can, do some homework. So it will be really helpful for all of us to be in the same page if you do some pre-tutorials. If you already used to Python and CentOS commands, that's very fine. Coming to the programming language, the Hadoop is basically written in Java. But don't worry, so it's not that without Java we can't write anything on Hadoop. So there are a lot of libraries being developed, let's say in Python. So we'll use Python to interact with SDFS and Spark. And I selected Python because I am also comfortable with Java, because Python is very easy language. So everybody can, if you have concept of any programming language, if you give few days time, it can be very easy to learn, and there are a lot of libraries, especially if you want to analyze large data sets. All of you may know that nowadays Python is a very demanding language for data scientists or data engineers. So Hadoop binaries, if you can see the basic binaries, but you can go through, don't need to download anything. Whatever binaries we'll be using, we'll share in a common location so that you can download in the due course. So that's all, I mean, for today's session, because I would prefer to keep around 30 minutes or 20 minutes time for question and answers. Hi, Ibrahim, is there any question already placed?
Yes, is almost 36 questions come from participants. You can see it.
Yeah. Okay.
Okay.
Thanks for all the questions.
Okay, it's a big question. 36.
Yeah, I'm picking up, I mean, one by one, and
Okay.
yeah. So, I mean, first question is from Ashish. Any online service for Hadoop to try out? I think we need to look into the Cloudera. So they are providing some online facilities. And as it needs to install CentOS on our machine for practical session, yes, I do recommend to install, I mean, virtual VMs, at least 3 VMs installed to the CentOS 7, so that you can create one Hadoop cluster within these 3 nodes and have the flavor of, I mean, distributed computing and storage. So I need to, I mean, get the question from the top. That would be better. I mean, can I use Windows instead of like Linux? So as I said, I mean, as a development platform, you can use Windows, no issues on that. But as my instructions and everything will be on CentOS 7, so if you are any problem with Windows, that would be time consuming to solve. So my request would be familiar with Linux, and you will get everything, I mean, documented, so you can go through. I mean, in the meantime, you can familiar with Linux environment. If I watch recorded video later fully, will you count? Okay. Can I use, okay, instead of Linux? Okay, is Linux OS is a must? I thought I answered your question. What tools or software will be needed to practice and prepare the assignment? So that will be, I mean, communicated in later course of time. But in high level, we'll be using CentOS 7 and Python. And then SDFS and Spark, you will get to know in the due course. Will there be any talk about big graph? No, it's not part of our curriculum. Which framework the big data used? Okay. So we are talking about the Hadoop distributed computing framework. It has 2 components, HDFS and MapReduce. But for distributed computing, we will use Spark, Apache Spark. Is there any data size threshold to be considered as big data? No, there is no specific data size limit. As I said, it depends on the company, I mean business, and their problems. So there are few criteria you will find in my, I mean, second or third slides. So that questions will clarify whether you need to go for a big data or not. For this course, I prefer to learn Python. Yeah. If you use offline, then latency is not an issue. Yes, right? But not fully right. So if you are processing or if you are trying to get analytics from a large amount of data, and your boss or your supervisor is asking to give a result maybe by 1 hour, your management, and you are giving after 2 days because you don't have big data to process, then what will happen? So latency is a factor always. It's not that it's totally open. Our Google and Facebook is Hadoop instead of their state of art data center. So Google is not using Hadoop. Google invented this technology, and they are using GFS. I mean, their distributed storage platform, and big table they are using as structured data storage for large amount of data on top of GFS, and MapReduce as a distributed computing platform. I think Facebook is using Hadoop. Yes. Yeah, the exam pattern. So the exam pattern for the theoretical course, it will be, I mean, MCQ type. But for the practical type, there will be some assignments which you need to, I mean, uh, exercise in your own machine. And for some cases, we will allow you to work in our lab environment. Can you use VirtualBox? Yes. That's what we are recommending, to use VirtualBox in Windows OS so that your Windows OS is not impacted. Is CentOS, I mean, mandatory? Yeah, so you can use Ubuntu, but as I'm saying that all the instruction will be on CentOS. So, and there are some administrative commands which differs with Ubuntu in CentOS, you know that. So then if there is any problem, I mean, so maybe there is no more time to support you on the Ubuntu. So if you are on CentOS, that will be very helpful. Is there any difference, I mean, in real node or virtual nodes? Yeah, it's recommended to use, I mean, physical nodes if it's possible for Hadoop clusters. But nowadays, I mean, virtualization technologies are improving, so many of the companies are using virtual nodes as part of Hadoop cluster. Okay. The duration of the class is 2 hours every day. Real-time query, yes, it's not meant to, I mean, support real-time queries, but nowadays there are solutions on even on big data to support real-time queries, but it has to be on the large data set. Otherwise, you can use RDBMS. Does offline batch processing means working on historical data, not the live data? Can be both if the live data is really, really huge. Minimum RAM requirement for production is, as I said, 16 GB. Okay. Again, on a professional level, how big the data should be in order to use big data tools? Is there any significant data size? In general, there is no basically the limit. I mean, so you have data, but what you are doing with data, that's very important. I mean, how your application is working. Maybe you have 1 terabytes of data, but your online data storage maybe 1 or 2 terabytes. Maybe you are archiving data. So we need to understand the use cases. As I gave some example, I mean, one application example. So maybe your online, the transitional database can be very low, but if you want to process a large amount of data that is archived data, maybe you can run big data on that. So I would not say in specific size. Mac OS, yes, is for development only. But I still suggest or recommend to use CentOS because it will be helpful for your learning and for us to complete the course on time. Requirement for Python and Linux. With basic Python, yes, you can continue because any specific libraries that you need to utilize in this course that I will try to cooperate. So my ask is to know about, get familiar about Python, just that's all. And it does not require, object oriented, all this stuff. It's just considered functional level programming. Will there be a question of updating data format? I'm not very clear about this question. Among three types of data structure, which data is most difficult to process? Is unstructured data, definitely. For example, we have a letter and it's having 100 lines, and from there we need to find out the words, for example. So, how we need to deal with an unstructured data, that depends what's the use case and how we need to work on that data. So someone can ask to find the line, someone asks to find the word, or if a word is there, how many times it's repeated. So it depends on what use case we are trying to retrieve from unstructured data. So a developer or data engineers, they have to look into it that way. So this is the most complicated part, yes, processing unstructured. My email address, yes, I think Ibrahim, you can share.
Yes, also your profile and short bio already uploaded in the website. So one request for participants, go our website and find the course schedule and presentation or video, all materials.
Is it our desktop or laptop connected to Hadoop servers? Yes, as users, you can, assign job to Hadoop, no issue. Is scale up and scale out used in combination at times? In a specific Hadoop cluster, it can possible. It's possible to scale up some specific servers, but the intention of scale out and scale up concept here is the scale up is not going to support large amount of data sets. But you are right. Scale out is the key concept, but yes, we can still scale up particular servers within Hadoop cluster. No issues on that. Does application code of each node in Hadoop cluster are same or different code for different nodes? So generally a programmer or a user will submit their queries, from a web portal, or from that web portal, our codes are internally converted and will be submitted to a master node. And that master node will be distributing the same code to all the machines in general. And it will be running on the data that is stored in that node. And the master node is finally accumulating all the results and giving back to users. So I hope I answered your question. What is timeout control? Yes. So timeout control, I think we discussed about, whenever a master node is assigning a particular job task to a particular node, so the master node is tracking all the tasks assigned to all the nodes. So let's say the timeout period is, for example, 30 seconds. So either that particular node is processing slowly, which is unexpected, or the particular node is totally down. So then the master will wait for that timeout period, and that particular task will be reassigned to some other nodes, so that The user won't, understand what's happening on the cluster under the hood. So there's the timeout, but there are a lot of timeouts. This is one example. Are you referring to traditional servers as state-of-the-art server? Yes, you are right. Can replication of data or breaking down jobs face failure by any chance? Yes, failure is always there. It's not only we assigned, a master node assigned a task to a particular node. It can even happen while assigning the job or while replicating the data to a node. We are not getting response from that node. So there are many use cases can happen. So all these failures is managed in central level, software level. Why new file system is designed for Hadoop over traditional file system? Because the traditional file system is generally built to work on a single machine in general. But here, we are storing a file in a distributed logical file system. So for us is a single storage, but the file blocks where it is stored, we don't know. It can be distributed in n number of machines out of maybe our 100 nodes. Does it work in cloudy? I'm not sure what does it mean by cloudy. If you're referring cloud, yes, it will work because cloud will give you either a physical server or virtual machines. It will work. Can we use other besides Cloudera for the production? Of course, you can use. Even you can use the base Hadoop and Spark in production. But as I highlighted, if you are using a lot of, couple of tools within Hadoop ecosystems, so you just need to consider the compatibility issues and others. And if there is any problem, if you need to go to that specific community for help. I am a Ubuntu user. Can I install Hadoop? Of course, you can use because it's basically a Linux kernel. Can I use Hadoop in Docker? Of course, you can use Docker. No issues on that. Do you need Linux or Windows 10 operating system will be okay? If you can have Linux in your virtual box, but you can still run your laptop operating system intact, no issues. I think presentation slide will be found in the website. Okay. Ubuntu 19, yes, you can work, but I recommend CentOS 7 for this course. Is there any simulation software to practice? Simulation software? No. We will try to allow you to access our lab, which will be already configured and you can practice. But that's possible only for HDFS. For Spark, there will be some limitations. So we'll internally decide and let you know, because the distributed computing, when you assign a job, maybe other student will be waiting for the resources, because in our lab we have limited resources just for educational purpose only. But for HDFS, you will have, direct flavor of running queries in the file system. Is Linux is must? I think I already answered. How to set up Hadoop cluster on CentOS. Yes, that is part of course, so you will know practically and you will get all this material. A very big is processed under a single machine. Maybe I would rephrase your word. A very big data is processed under a logical machine. Under that logical machine, you will have a lot of nodes. Yeah. So, is there any book or something that I would suggest? I mean, uh, to overcome gaps or to have clear understanding. So in each of my slide, you will find the reference page. So the reference page will listing out, I mean, all the details from where I collected all this material. So if you go through all those details, you will get more clarity. I mean, if you have any confusion. At least how much RAM do we need to allocate from VirtualBox to do the practical tasks later? Okay, 4 GB RAM. 4 GB RAM, I mean, it would be better if you have 8 GB, but 4 GB RAM you can give it a try. Maybe with 2 virtual machine, not 3. Can you please give concept through in Python? Yes, there is a class. I mean, we'll expend some time on Python, but it will be limited because we need to get into the Python libraries that is required for our course. PC requirements, I am saying, I mean, few cores and at least 8 GB RAM would be better. Otherwise, creating 3 virtual machines, I mean, especially on Linux, would be really tough to run. But if you have any resource constraint, please do configure 2 virtual machines. Jupyter's, yeah, it's generally used to keep the configuration safe so that if something goes down on master node, we still have the configuration. Can we ask question before the next class? So I don't know, Ibrahim, you can clarify. Can we ask question before the next class in an email address maybe?
Okay, if any questions, they can email us and I make a list.
Yeah.
Okay.
Is there any big data that is provided by any web source? What type of PC configuration is required for doing assignment? Okay, I think that is already communicated. For today, there is no assignment because what I understand, still the registration is going. But from next class, there will be assignment. There's working cloud data center system service connected. When one data center is down. Yeah, when whole data center is down, I mean, if their site is down, still it can sustain, but it's depending on the design. Resource download link that will be provided. Okay, so there is a request, I mean, Ibrahim, that to use, I mean, Zoom whiteboard or Blackboard while I am describing. If it's better if I can write something. So I think
Yes.
that feature is available, right?
Yes. Yes.
Okay, so we'll try to follow that next class. Thank you for the solution.